Hello friends, so now we'll discuss the rules for nomenclature of coordination complexes. So as you can see, the first rule says that in an ionic coordination compound, the cation is named first and then the anion. So we have to identify which is the cationic part and the anionic part in an ionic coordination complex, and then we'll start with the cationic part first and then the anionic part during nomenclature. Now the second rule says that neutral complexes which are not ionic have to be named in a single word. Then the third rule says ligands are named first and then the central metal ion, that we have seen in our discussions in the earlier slides also, that we name the ligands first followed by the central metal ion. Now the fourth rule says ligands are named in alphabetical order. So this we will see while discussing this example. So now in this example, as you can see, we have three different ligands. We have chloro, we have nitrito, and then we have amine. Now if we start naming these ligands, so we have to follow the alphabetical order. So first we will name the amine, then we will name the chloro, and lastly we will name the nitrito N. So while naming these ligands, we follow the alphabetical order. Now rule number 5. The rule number 5 says that when we name more than one ligands, which are simple ligands, we put the prefix di, tri, tetra, penta, etc. And for complex ligands, we use the prefix bis, tris, tetrakis, etc. So we can see in one example where we have a complex ligand. So here we have an example where we have a complex ligand, and this ligand is methyl isocyanide. So how many methyl isocyanide ligands we have? We have 6 methyl isocyanide ligands. So instead of naming it hexa, we will name it as hexakis. So we will name this ligand, we use the prefix hexakis methyl isocyanide. So for complex ligands, we use bis, tris, tetrakis, pentakis, hexakis, etc. and not the simple bi, tri, tetra, hexa. So like this it is not used. So we use a special prefix which is this. Okay. Now moving on to the sixth rule. So it says that anionic species, where there are anionic species as the central metal atom, then their names end with ate, 8, while the cationic species, if the central metal ion is a cationic or neutral species, they are named as such without any characteristic ending. The last rule says that the oxidation state of the central metal ion is indicated by Roman numerals in parentheses like this. So if the central metal atom or the central metal ion has a +1 oxidation state, or +2 or +3 or +4 or any oxidation state, so it is indicated by the Roman numerals 1, 2, 3, 4, etc. within brackets. Now quickly I'll just once again I'll go to point number 6 and let you know that had this been an anionic species, so here it is the cationic species, the central metal ion is a cation, and so there will be no change, the metal ion will be named as such. However, for anionic species, the platinum would have become platinate. So similarly, if iron was a part of an anionic species, then it would have become ferrate. And if it was a part of the cationic species, iron would have been named as iron only. So these kinds of nomenclature and the rules we will elaborately discuss in further examples, so that all rules are clear and we have the applications of all rules in our further examples.